Hi, and welcome, and thanks so much for RuPy for inviting me here. My name is Piotr Szotkowski. I go on the internet by the nickname Chastel. And what I want to talk about, as I was introduced, I work at a university, and I'm the CSO at Rebase, so if you have any consultancy work to be done, just give me a note. The assumptions for the talk today is that you usually know there are nifty things you can do with different tools in your shell and maybe with actual programs, but you don't usually you don't usually learn a lot how to do them. You've seen some blog posts that describe those tools in excruciating detail, 40 options for every feature that you want to learn, and there's usually something in there that you like, but you don't remember it the next day. So the idea is that it would be cool if someone actually showed you a couple short tricks that are useful on an everyday basis, and especially if they are not well known. So I apologize in advance if all of you will know everything that I will show up today, but I hope at least some of the things that I want to show are worth it. So the tools I want to cover, there are basically three parts to this talk. First Git, then PostgreSQL because I love it and it has a lot of unknown features. And then obviously Vim because as every Vim evangelist, I have to evangelize about my favorite editor. The third one is command line, and there are a lot of things you can do on the command line that people are usually scared of, but are very simple when you get down to the details. So Git, as many of you know, is very simple once you understand how it works. It's really easy once you get the basic idea that branches are homomorphic endofunctors mapping submanifolds of a Hilbert space. But the truth is, once you actually understand what Git is underneath, it gets very simple. There are some very nifty things you can do, like naming a remote branch head in capital letters, and this will really trip up your coworkers. You can do UTF branch names if you want, because they are just file system names. You can use subversion remotes with Git, which is how I ended up working with a certain project that used subversion for years on end. And actually the tweet that made me present this talk was this one from Tom Stewart about Git rebase --interactive --autosquash, which is one of the very nice Git features that not many people know about. So let's start with a quick rundown of a Git workflow, example Git workflow. Let's start with our typical world domination project in temp, because we do them like twice a day. The first thing that I always want to do is create an empty Git commit at the root of the repository, because you can't really edit the first commit. You can't squash against it. So if you have an empty root commit, the next commit will always be editable, the one that actually has some substantial changes. And you can actually, when the day comes when you want to throw everything away and start rewriting, you have a branch point that you can branch off of without any clutter in there. So let's say we have a nicely hashed, ageless commit at the root, and let's see we do README-driven developers as we always do, and let's add it, commit it, and we have our first commit that got the hash of cabbage because we are very lucky with hashing. So let's actually start some work. Let's create our first actual working code. Again, add it, commit it. We have this, and then suddenly we figure out that we have these three nice commits: the root one, the one with the cabbage one with the README, and the codeful one with actual code. But we want to change something in the README, and we don't want to actually show it in history. We want to capitalize the fact that we are doing a README-driven development. So we replace all the lowercase characters into uppercase characters. We use Sponge, which is a very nice program that lets you pipe into the same file without obliterating it in the process. So it basically sucks the input, and then when the pipe input is done, it writes it to the file. And we add it, we commit it, and if we say that this particular commit is a fix-up for a different commit that was somewhere in the past, with saying fixup bank space and the SHA. Then first we have a separate commit. So it currently looks like this. We have the ageless root, the cabbage one with the readme, the code foo with the code, and then the seafood one with a fixup. But if we now do git rebase interactive auto squash with the parent of the cabbage, then Git will actually, by default, do what we end up using manually otherwise. It will actually squash these two commits, so cabbage and seafood, into one commit. And as long as you didn't push your changes to the remote repository that somebody else uses, this is a very, very quick way of fixing very embarrassing typos or something like this. So now we have changed bad food commit that squashed cabbage and seafood together, and then we have a different commit for the code change. But this is a useful thing when you want to really change something that you are very embarrassed about, which at least some of us do all the time. So, okay, let's go further. Let's say we have an RVMRC file, which is a typical config file that people cannot really agree whether it should be committed or not to the repository. I think it should be committed, but there's often time that we want to adjust it for our own use. Let's say we want to bundle every time we change to that directory, but we don't want to force all the other developers to change it. And if we do that, we end up with a dirty working tree. So now we have a configuration file that is in our working tree. It has local changes, but we don't really want them to be committed upstream. We can either very painfully avoid committing those changes, which will eventually happen anyway. But we can also just say to Git, please update your index and assume this file is unchanged. And now when we see the status of our working tree, we can see that this file is no longer assumed to be changed by Git, even though we have local changes. And this is clever enough that whenever somebody updates the upstream repository with the changes to, in this case, .rvmrc, those changes will be pulled down to you, and you will get a conflict. So you will know that your local modifications that are just hidden from Git, they are no longer the ones that you thought they were. So this is actually quite safe to do, and it works in many situations when you have local changes to something that probably either shouldn't be in the repo, or there are very compelling reasons why it should be in the repo, but you really want to have local changes. So the last set of Git tricks I want to show is, let's say we have our new branch, Pinky, and we want to actually change the way our world domination works, that it works only if we are the brain, and otherwise we don't necessarily go right out into dominating. So if we have this kind of change and we do git diff, we can see that the diff is across the whole file, because we indented the single line that didn't change. But oftentimes we really don't want to see what in practice is whitespace changes, especially if we have somebody who does obsessive-compulsive development and really wants to fix all the trailing whitespace and indentation and so on. If that person does this, we don't really want to see it sometimes, and we really want to check whether the code looks like it should. And there's a git diff -- ignore all space or -w that ignores this. So if you really want to produce a whitespace-only changing commit, you can check very quickly whether it is indeed only whitespace changing. So let's add this file, committed. And the last thing I want to show you with Git explicitly is, do you know there's in Bash, and I'm pretty sure in all other shells as well, there's this cd --dash command, which changes you to the previous directory you've been in. So if you keep repeating cd dash, you keep changing between two directories. In Git, you can do exactly the same. If you have two branches, you can do git checkout dash and switch to the previous branch you've been on, and then switch back again. This is surprisingly useful in many cases. For this talk, I have it on GitHub in a master branch, but I have the compiled version as GitHub pages. And I kept changing just between those two branches all the time when I was working on this. So to summarize, git commit all empty. Do consider creating empty commits at the roots of your repositories. It makes sense for me. git rebase -i -- autosquash, update index assume unchanged, git diff ignoring whitespace, this is often useful, and git checkout dash, especially if you shorten in your git configuration checkout, so say CO, then git co dash is really quickly to type, and you can have even shorter alias. Now, the last thing about Git, who here knows what git add dash patch or git add dash p does? Okay, those who raised their hands, your first homework assignment is to explain it to one person who didn't raise their hand, because it's one of the best features of Git that I use daily. It allows you to add changes on a patch-by-patch basis or chunk-by-chunk basis. So you can add some changes from that file, but not others. And the other thing that I actually didn't know about is that it actually also works with git checkout and git stash. So if you have 20 changes in 15 different files, and you want to revert only one of them, you can go do git checkout dash p, and then it will go through all the changes and ask them one by one whether you want to revert them or not. This is really useful. Okay, let's go with the next part of the talk, PostgreSQL. People usually, the first problem with Postgres is that they don't know how to pronounce it, and it would probably help it if it wasn't named this well. But there are reasons why it's called PostgreSQL. Although there is now a very small movement that consists of one tweet and my person. The tweet was, though incorrect, PostgreSQL is more fun to use when you pronounce it as PostgreSQL. I think this is something we should all get behind. But the real value of PostgreSQL, in my experience, is all the things it can do that people assume, that people don't even know that it can do them because they are not usual things that RDBMSs do. And if you visit this page, you will see one of the very nice PostgreSQL documentation pages showing you some of the nifty features that PostgreSQL can do. So let's start playing a bit with PostgreSQL. We have a RuPy database. It runs the newest PostgreSQL because one of the features is only in the newest versions. And first, you can have your own types of columns. They can vary for trivial enumeration columns, like the type of the track a given talk is, either both tracks or first or second track. But they can also be all kinds of different types. They can be compound types. They can, well, do read the documentation. They're awesome. Let's say we create a table agenda for this conference, and it consists of the column track of the type track. It has some info on speakers, titles of the tracks, abstracts of the talks, but it also has a timestamp with time zone range column, which is a range, in this case, of timestamps with time zones. And it has a column called tags, which holds arrays of strings. Not many people know that PostgreSQL does that because not many databases do this. So let's see what happens. Let's insert a registration that was between 8:45 till 9:30 now. And if you spell it this way, it means that it included the 8:45, the lower bound of the range was inclusive, and the upper was exclusive. It did not include 9:30. If we select from the database, you can see that Postgres actually did interpret this correctly. It actually manages time zones properly. I don't know how many of you worked with MySQL and time zones, but PostgreSQL actually makes them work in a very sane way. And this is a type of a column that is a range. It's not two separate columns that say start time, end time. It's a range of things, in this case, timestamps. So let's insert Z's keynote. Let's insert also Joseph Valim's talk on Elixir, and let's tag it with Elixir and Erlang. And the way you tag, you create arrays of strings in PostgreSQL is basically the string representation is this. And let's also insert the extendable Django apps talk as well that run concurrently to Joseph. And if we now select it, we can see that we have a column that holds arrays of strings, and these arrays can be of anything. They can be of integers. They can be arrays of arrays. There is an example that runs tic-tac-toe, like 3 by 3 arrays in every cell of a given column. And after we insert some more talks that were today, again with different number of tags. This has 2 tags, this has 1, this has 3. We can see what we now have in that table. And we can, in this case, we take the lower bound of this range, so the starting hour, and we just display it as the hour rather than the whole timestamp. So PostgreSQL obviously has a lot of functions, but they are often quite nifty, and you can do a lot of things on the database side. But we did this because it actually makes sense for a time range, in this case, to be represented as time. If you wanted to see where you could go at 1020, you can say select where the time range includes this particular timestamp. And these were the 2 talks that happened at 1020. If you came to the Ruby Python conference because you're interested in Erlang and JavaScript, then you can do this, and it will show you all the talks that are tagged with either Erlang or JavaScript. And you can do all kinds of things, and for quite surprisingly many applications, it actually makes sense to denormalize these things in this way, to actually have a column that has arrays that is indexed, that you can query in different ways. And the last part that I want to show about PostgreSQL and its features is we have this abstract column that holds all the abstracts for the talks. And I will abbreviate it a bit now. But PostgreSQL actually allows you to have a column that stores the term search vector for every text field. So it will, if you look at the middle column, it's basically tokenized version of the string with every whitespace separated word being treated as a separate token. And you can actually also tell Postgres that you want to normalize it for English in this example. And if you take a look at the last line, the C++ token got normalized to lowercase c. And if you look at the second line, the challenges word got normalized to just challenge prefix. So you can do a search against any kind of word that stems with challenge. And as you can imagine, Postgres does not only have a term search vector, it also has a term search query type. So if we want to find all the talks which abstracts, when casted to a term search vector, include term search query Haskell and Ruby, then we would find the Rust from Python and Ruby talk. But we can also do database-side searches for something that is, let's say the user submitted as the word challenging, and we want to make Postgres it, stem it, and this will select that talk even though the word was challenges. The user submitted challenging, but the PostgreSQL did all the stemming on both ends and matched it. So I really like PostgreSQL. I really like its custom types and ranges and arrays and search and all the different things that PostgreSQL does out of the box. And I think I really agree with this quote from Ryan Smith. I truly believe that PostgreSQL is the hacker's RDBMS. Do play with it. It's full of nifty tricks. Even if you don't end up using them in production, they will expand your ideas what can be done on the database side and whether maybe PostgreSQL is not the database that you should try in your next project. So the last part that I want to talk about is command line interface and all the things that we do on the command line. There are tons of command line commands useful on an everyday basis, and this will be just a crash course through some of them. And there will be some examples of command chaining. I'm pretty sure you all know what it is when you have command after command separated by pipe characters. The obvious quote for this kind of disasters when they do end up blowing up is this one. But if you learn only a couple and you understand how they work, you usually end up not blowing up your computer all the time. So in the long run, it's, in my opinion, very useful to actually know them. So I had a slide here that enumerated them, but then I decided to just show examples of how they work one by one. Let's find all the model files in a Ruby application, but this can be easily translated to Python. All these examples are actually language neutral. So let's find all the RB files in our model directory. This will be this kind of listing. If we pipe this kind of listing into xargs, xargs is a program that takes its first set of arguments. So in this case, wc-l, which is a program that counts the lines of all the parameters that are passed to it. And what xargs does, it turns this list of files separated by new lines into a list of files separated by white spaces. So it passes this to wc-l. So you end up with a list of files and the number of lines they have. If you now pipe this into a sort program, which sorts the input, -n means sort them numerically, so sort 2 before 11 rather than after in alphabetic order. So sort them numerically and show them in reverse order. You can see a typical Ruby application when you have a couple of awful models that are really, really huge, and the long tail, in this case, it's actually a large application, so there's a long tail beneath, but there is this one pain point, a model that has 3,600 lines. And this is a very nice trick to check in new race applications you're about to work with, but actually any project, to very quickly find the large files that probably are the most painful points of the application to work with. This trick is from Sam Livingston-Gray, and if you don't know about the Ruby Rogues podcasts, I highly recommend that you learn about it and start listening to it, and I urge you to subscribe to the mailing list. It's paid, but it's paid $10 a year, so it's not very expensive, I would say. And there are a lot of wonderful discussion on this list, and this is one of the commands I got from this list as an example. So let's go further. Let's get a Git log that shows the one-line Git information from the commit message, and then name only means display only the files that were changed in that particular Git commit. If we grep out only the file names, we have a list of file names that were changed in each subsequent commit. If we now pipe them to sort and then to unique-c, unique-c will basically tell you how many times a subsequent string occurred. So it will tell you how many times a given file, in this case, occurred in this list, but it needs a sorted input. We now have an information that the cooks controller was changed by 4 commits, but the other controller, cooks, was changed by 183 commits. And again, if we pipe it through sort-r, we can see that that particular model that we just learned is 3,600 lines was also changed by almost 1,100 commits, which again is a great way to check what are the pain points of the project you're about to work with and cry in advance rather than only later. This was from Samson Otovac, and this was originally tweeted by Michael Feathers. So 2 very useful tricks that once you know about 6 different command line applications at most, you can mix and match them in very, very different ways. So let's see one last example. Let's say we have a file that is a log of Rails migrations, and it's a very long list because they took a very long time, and we want to see how much time they took. We can grab out the migration times, which are basically strings, the lines that have an arrow in them and some numbers and then s for seconds. We can cut. I'm doing this a bit extreme example because I want to show a couple more tools that I use every day. So what cut does, it basically cuts every input line on the specified delimiter, so on spaces, and just takes out the 5th field in this example, so only the times. We can use tr to delete all the characters that are passed to tr, in this case only s, from every single line. And again, we can do xargs, which, if we don't give it a command, it will just switch subsequent lines into one string of lines separated by spaces. If we now, again, replace with tr spaces with pluses, we get a list of numbers concatenated by pluses. And we can actually just pipe it to BC, which is the command line calculator, and we can see that all the migrations took 4 seconds. It is a bit of a contrived example, even though I actually used it on production code a month ago. But again, there are only a couple of tools that if you learn how to work with, you can do. I mean, it took me maybe 2 minutes to combine this all to get the total migration time. Next to last example is PiedViewer. PiedViewer is a very simple program that you put between 2 pipes, and it shows you how fast the data flows between those programs. So in this case, there was by the time we Control-C it, 97 megabytes that took 12 seconds, and the current flow was 28 megabytes per second. And if you actually give it a name that it knows the size of, it will show you a progress, how much does it take. So if you are piping a database dump into somewhere distant, for example, you are loading an Amazon database with it, then you can see whether you have time for coffee or whether you have actually time for lunch, or maybe you can just come back tomorrow. And if you don't know the size, you can hint PV to just assume that this dump will be 600 megabytes. And if it's shorter, it will just stop at 98%, like in this case. But also, it keeps the estimated time of where it should finish. Very useful. This is a very quick example that I got from Katrina Owen, who got it from Gary Bernhardt. You select some code in your editor, you make it paste into the command line, you pigmentize it, which means colorize it with Ruby syntax, RTF output, and for presentation, and then you paste it back to your clipboard. So then you switch to your presentation software, and if you're not using something like show-off like I am, but something more like proper presentation software, then you get colorized input right for your slides. This is very, very useful if you do this kind of presentations. And this is something that I used to do really, really often by hand, which is take a result of something, take a result of almost the same thing for a different directory, and compare the output by hand, first piping this to files, and so on. You can do actually subshells, and you can diff 2 outputs of 2 programs by doing just this. So just a quick list of other notable CLI command line interface tools that I use very often. pgrep and pickle let you grab and kill processes by name or by their PID. So if you want to quickly kill all the orphaned processes because you had, I don't know, 20 Firefox instances to kill because they got orphaned, this is a very simple way to do this. If you ever repeatably run a command because you wanted to see how its output changes, because it shows you a status of something, there's a command for this. If you prepend that command with watch, it will rerun it every 2 seconds by default and show you the output. Very useful. Timeout. If you have a program that you want to kill in 10 minutes or in an hour, or run it with different parameters every hour, timeout will kill it unless it actually finished cleanly before that. This is very useful if you do any scientific computations that you want to run a given amount of time. GNU parallel. This is it's very hard to explain it. It's by default it's just for running things in parallel. But if you read the documentation, which is linked in here, it does very, very many very cool things. And the documentation is full of examples how to use it for queue management, for example. NCDU. If you have a server and something takes a lot of space and you are not sure what, you can run NCDU and it gives you a graph, textual graph information, which directories have the most stuff in it, and you can drill down and delete stuff from inside of it. And proxy local is awesome if you want to expose your local database to the outside world, like localhost port 3000 to somebody who is in Australia and not necessarily in your local network. Proxy local will just expose it under a public domain. Armadison, if you want to check what version of PostgreSQL is in different Debian or Ubuntu releases, this will show you by querying it remotely. Gets useful more often than you think. So to conclude, there are a lot of commands. If you end up using a command very often, you probably need a alias for it. If you don't have this alias on your computer, you are missing out, because it allows you to do things like this. The other one is to alias sudo to fucking. But computer apt-get install PostgreSQL. I urge you to do this and play with Git and PostgreSQL and learn a little CLI, like 6 commands for starters, and then expand it as you walk. And do subscribe to Ruby Rogue's mailing list. Do watch this presentation. It's an awesome presentation about PostgreSQL. There is a very nice blog of short commands that are very useful, but they are not overwhelmingly complicated. And there's also CleanMagic Twitter account, which shows you tweet fitting CLI magic. And this one in particular, if you run it, let's say twice a week, it will show you a random man page for a random command on your system. Can be really enlightening, especially if you happen to find by pure chance the documentation for mancoder or any kind of application that has 500 man pages. So thanks. This talk is available on talks.chastel.net, so all the links work there. And again, thanks you so much for watching this. I don't think we have any time for questions, and I'm standing.
Well, now it will be a break, right?
Okay, so I'm standing between you and the coffee, so I'm not risking any open questions. But if you have any, please come up to me, and I really highly recommend playing a bit with the stuff I showed.